Question 1. An object is accelerating at a constant speed of 40 meters per second. So it's a constant speed in a circular path of radius 80 meters. Calculate the acceleration of the object. So we're going to use this formula over here. It comes from your data booklet, as we can see down over here. And we have got here our velocity is equal to 40. So it's 40 squared divided by 80. So we're going to get 1,600 divided by 80. That's 0, and that's going to equal 20. So it will be 20 meters per second to the minus 2. Now, the idea with this, the acceleration is 20 meters per second to the minus 2. It's not accelerating in the form that it is changing the magnitude of the velocity, but it is changing in its direction. For question 2, a body of mass 5 kilograms lying on a horizontal smooth table attached to an extendable string. This basically means is that it can't stretch, doesn't stretch. And it's of length 0.35 meters, while the other end of the string is fixed to the table. The mass is whirled at a constant speed of 2 meters per second to the minus 2. Calculate the centripetal acceleration. This here is our centripetal acceleration. Then we have the tension in the spring. This is the in the string. This is the force, and then the period of motion. This is the time taken for one complete oscillation. So, firstly, as before, we're going to have that our acceleration is equal to v squared, this divided by r. So we have got 2 squared divided by 0.35 meters. So that's going to equal 4 divided by 0.35 meters, and that will be meters per second squared, like that. The tension in the string, now there we go to our Newton's first law, F is equal to ma, so F is equal to ma, so we can just put this in. It's going to be 5 times 4 over 0.35. So that's going to equal 20 over 0.35. I'm not doing the final calculations here. You can do that. And then the period of motion. Now the period of motion is basically given by this formula over here. Because when you're looking at the period, you've obviously got this going around in a circle. The distance that it actually travels, the total distance that it travels, is the circumference of the circle. And if this is r, the circumference is equal to 2 pi r. Because it's going at a constant speed, notice here it says it's going at a constant speed, your time is equal to is going to equal to distance divided by your velocity. This is equal to 2 pi r is your distance, total distance all the way around the circle, and your velocity is given by this over here, so that's going to be 2 meters. So it's going to be 2 pi r. I can just take this away over here. We've got here that our r, we are told, is 0.35, so we're going to get 2 pi times 0.35 divided by 2 will give us our time, and that will be the period, because the period is the time taken for one complete oscillation. Now notice your units here, it actually works out, because you want a unit here of a second. Let's just look at our units. We have this r, that's in meters, and we have our velocity is in meters per second. So when we divide meters divided by meters per second, that cancels, and the second to negative 1 comes up to the top and becomes just your seconds.